Now let's try to concatenate two problems. Concatenation is nothing but taking first one and then adding the next one. So let us say strings should start with A and end with B, starting with A and ending with B, right? So first one is language L1. Let us write only for starting with A. So the smallest string which starts with A is A, and next one is AB or AA or AAA, so on, right? And L2 is ending with B. The smallest string which ends with B is B or AB or BB or AAB, so on, right? Now it has to, the language has to start with L1, start with A and end with B. Therefore let's try to concatenate these two. So concatenation is nothing but take one string from L1 like this. L1 concatenated with L2 is take one string from L1 and then append the one string from L2. So which means the smallest string is going to be AB, starting with A, ending with B. Or next one is going to be, you can either see, you can take this one and you concatenate this A B and A B B, so on, right? So we have already seen a DFA for L1 and we have already seen a DFA for L2. So now you can draw different DFAs for both of them and then you can merge them, or you can even try directly. Let's try directly first and then let's show you where is L1 and where is L2. First thing, always draw the skeleton. What is the skeleton? For the smallest string A B, skeleton looks like this. Okay, so this is the basic skeleton. Now what if I get B here? So what does this state A represent? This state A will accept strings only starting with A. If it is starting with B, I should not accept it and I am going to kill it. If any string starts with B, I am going to kill it. Now what does this state B represent? This state B, whenever it sees small b, it thinks that it is the last b and it is going to go to next state and accept it. So any number of A's if it gets, it should not change the state. It is accepting for the b. Once if it sees b, it will think that this is the last b and it is going to send it that way, right? And what does C do? C is C, whenever we reach C, it is nothing but we are ending with B. But if I get a, see, how did we reach C? We have reached C on seeing AB, nothing but all these strings ending with B. Now if I see A, again C has to wait for one more B to accept it. Therefore if it sees A, it will wait for one more B to accept it, one more B to accept it. And in C, you have seen AB and you reach C. Now if you see any number of B's, it is nothing but ending with B itself. Therefore any number of B's, it is going to be, we are going to be here. Got it? So this is how the final answer looks like. The final answer look like. Now let us draw the DFAs for both of them independently and see how can we connect them. For L1, starting with A. So we have already seen it. Starting with A is nothing but, if I start with A, I am going to accept it. And if I start with B, I am not going to accept it, right? And L2, ending with B. If it is going to end with B, I am going to accept it and I am going to wait for B, and once I see B, any number of B's and A, right? Now you just look at it, L1 and L2. L1 is actually like this, some part of B and then these two, this and this and this and this, they are similar, right? And L2 is nothing but this part, some part of it and this one. So L2 is here and L1 is here, which means I have taken one automata and I have concatenated with other automata, right? So you can directly draw it, but then you can even take this and then concatenate. Only difference is this one. you have to take the final state and you have to concatenate it. So easier way is, if it is not, for DFA, you can even take NFA and then club it using an epsilon move. We shall see it at NFA, how to club to how to concatenate two automatas. But then my intention is to introduce you to the concept of concatenation using this example. So we have concatenated two languages, and so this is the finite automata. It exactly looks like concatenation of two finite automatas. Okay, fine.